Okay, bienvenue à tous. Welcome, everyone. And it's a great opportunity. We have a good cross-section of people here today. And it's a good opportunity to have a conversation about the future of electricity in New Brunswick. And that's what we want today to be. It's more of a conversation, and we want it to flow. But we're going to take you through a little journey about where we see the future of electricity going in partnership with Siemens and the business sector in New Brunswick. So these are definitely exciting times, and I'd like to welcome everyone. Just another little safety tip, because we like to do this. There's a lot of water on the road today. Some people may be traveling. Watch for hydroplaning. Tomorrow morning, that'll all be ice. So, you know, just little things, slips and falls, it takes you right off your golf game. That's not good. So another little safety tip for you. Okay, let's go back to last Thursday morning. Minus 32 degrees wind chill, I think we all recall. 7 o'clock, 8 o'clock in the morning, we hit a peak of 3,117 megawatts. We'll show you that a little later. We're burning oil. So what's going on in our lives at that time? 4 showers in our house. Heating systems are cranked up because the homes weren't preheated, so a lot of them will turn the heat up in the morning. And we have an intense electric heat in New Brunswick and hot water. Everything's going on. Lights are coming on. Appliances are going. Demand soars. Over a 5-hour period, 700 megawatts of spike from last 2 o'clock in the morning on Thursday, to Thursday morning at 8. So 2 or 3 in the morning. So you're looking at 700 megawatts, the equivalent of a Point LaPro. What I want to talk about today is the future of electricity. Has a lot more to do about how we utilize electricity than how we generate it. And what really creates the opportunity when we talk about the smart grid and intelligent information about how electricity is utilized is that end-to-end connectivity that says what was going on last Thursday at 7 o'clock. How could we have made that spike 600, 550 megawatts instead of 700 megawatts and perhaps not had to burn oil? Because there are times we burn oil and we pay a premium of 18 cents a kilowatt hour and we get 11 back, right? Those are what we call peakers. We have to have them. We're good to go. We can supply the load, but there's a premium to do that. And in the industry, the top 20% of steel in the ground gets used 1% of the time. Okay? We generate electricity to meet the demand. So the future, and on top of that today, we have wind, we have renewables. We'll talk a little bit about that as well. They come, they go. Sometimes the wind comes when you need it. Sometimes the wind comes when we don't need it. How do we optimize the usage of that electricity so we could store the wind perhaps in hot water or in heating solutions in the future? So how do we create that dynamic link between the generation and the usage, and the link is the smart grid. And when we talk about the technology and working with Siemens and going end to end, and we saw the big data conference last week, that's really what we're talking about. Hundreds of thousands of meters collecting data every 5 minutes, information on how electricity is utilized and leveraged so we can better optimize the system end to end. Better tools for the customer to save money, manage bills more effectively, but better tools to manage the entire system end to end. I think I gave the whole presentation there, anyway, that's good. Good start. But, you know, the key is we know when we go to the gas pump how much it costs us. The issue is last Thursday morning we had no clue, for the most part. There's industries and commercial customers that have a pretty good handle on how they use electricity. But for the most part, the residential customer at the end of the month gets a bill and says, oh, okay, we have to get better than that in the future. That's when we talk about the future is about the usage as much as about the generation. So how do we optimize that? Most people think of electricity 6 to 8 minutes a year, okay, at the present time. So again, we have to go there and work that forward. So what I'll talk about today, I'll go quickly on this: energy policy, strategic objectives. Brent hit on a few of these. Why reduce and shift demand? What is reduce and shift demand? What is smart grid? What's in it for me? Why? Why would I? Some initiatives and the key to working together going forward, because the solutions really are amongst all of us. Energy policy. October 2011, clear direction for the future of the province for energy. Well laid out, clear guidelines to the future. Low and stable energy prices, critical. We've had low and stable energy prices in the past. We want to continue that in the future. People tell us we want to see less fossil fuel. We want to see more renewables over time. But we don't want to see a price increase, and we want reliable power. Okay? So, and then they say, you guys go figure it out. But what we're here to talk about today is in order to accomplish all those objectives, and instead of having that 700 megawatt spike last Thursday, make it 500, that's where the partnership starts. That's where we have to start working together, and we have to be astute as to how we get there in the future. Energy security. We all heard about energy security. We've heard a lot about electricity and energy in the past 3 or 4 years. Very important. Onset of renewables. Reliability of the electricity system. We've got a robust transmission and distribution system. We want to maintain that. Very important to the province. Very important going forward. But when we talk about the future, you've got distributed generation out there, solar generation in homes, distributed wind, and a whole lot of dynamic going on the distribution side that wasn't there before. It's good. It's renewable. It creates opportunities and challenges as well because people want reliable electricity going forward. And that's what this is about as well. Smart grid, bringing on an intelligent utility network, the work with Siemens. Environmental responsibility, burning less oil, better integrating renewables, offsetting the need to build down the road because we're using it more intelligently as a whole, and maintaining low and stable rates, very important. And effective regulation going forward. There's going to be some more rigor put into the regulatory system in New Brunswick. 40% renewables by 2020. All things that were made clear. If we look at New Brunswick and our interconnections, strategically situated and interconnected. We buy from Quebec, great partner. We can sell to the US, and we trade with Nova Scotia, and we supply Prince Edward Island. So we're strategically located. And if you see, we've got a good diversity of generation. We've benefited from that for years. But what we've seen in the last few years is the onset of wind generation. We're at 300 megawatts of wind in New Brunswick presently. And if you look here, we're at 800 in the Maritimes. Total in Canada is around 6,000. We have a good, solid penetration of wind in the Maritime provinces and New Brunswick, as high as anywhere in North America on a total capacity basis, and as well as Texas and the Northwest US. So what we've got to learn to do is handle the wind we've got effectively. Wind is a great complement to the mix, but it's got to be managed. Because sometimes the wind blows and sometimes the wind doesn't blow, right? So there's a bit on our system. And we've got LaPro back on, one of our major assets back online, which is a great thing. Going forward, our strategic direction, sustainable electricity, low and stable rates, reliable, economic electricity, but environmentally responsible going forward. That's what people have told us. That's what customers tell us. That's what they want from us. What do they want? They want a well-run utility. They expect that, and we're working at that. We're looking at debt reduction towards $1 billion over the next 10 years. So they want, and that's very important because we've just finished our major capital programs. LaPro's back on, and we're going to curtail our major capital programs, but we will invest in smart grid because it's critical going forward to us. The reduction of $1 billion of debt, top performing utility, more effective and productive. We've taken out about $35 million worth of costs. We continue to do attrition at the utility. It's a different place. It's leaner. It's meaner. That money can help us reduce debt over the years. As well, when we talk about reducing shift demand and burning less oil, and perhaps not having the need to build down the road, it enhances our opportunity to reduce more debt because it helps us become a top-performing utility. The smart grid is really fundamental to all of that. So I think what we see here is that sustainable electricity in the future is critical, and that's where we're heading. Looking at last week, okay, that was last week, minus 32, 3117 megawatt peak. And you see here the top end. But what you see is that's Thursday morning at 8 o'clock, and on the left side you see Wednesday night at supper time. You see a valley here at about 2 or 3 in the morning of 2450 megawatts. So over a 5-hour period, we saw a jump of about 650 to 700 megawatts. Okay? That's real. That's how we use electricity. That's the baseboard heating. That's the hot water heating. That's what's going on in our homes. That's what's going on in our business. But a lot of that is electric heat and hot water heat. So going forward, challenge. How do we make that 550 megawatts instead of 700 or even 600? Because that could prevent us having to start an oil unit at Colson, perhaps on a negative margin. So the key is how we use electricity going forward really does make a difference, and how we promote that dynamic partnership going forward. And that's the work we want to do with Siemens. So if you look here, ideally, if we're heating hot water during that peak period, and we've got 220,000 hot water heaters in New Brunswick, can we heat some of that hot water before or after that peak period? How do we optimize that time frame? Technology will allow us to do that going forward. And as well as heating, there's heating systems in the UK today. They heat bricks. They heat them between about 11 o'clock at night and 7 in the morning, midnight to 7 in the morning. They offset significant amounts of load, and this is called thermal storage heating. Going forward, we may want to look at solutions like that. So again, taking from the peak into the valley, very important. And at the end of the day, we end up with a better, smoother load curve. But what that can also do is offset the need for the next unit 10 years later. Another thing we can do with hot water heaters is if the wind happens to be blowing at noon, maybe we want to charge them at noon and we know there's a wind forecast coming, we can line up wind forecast with charging of units. So how do we optimize the integration of renewables? Because people want to see more renewables, but creating that dynamic system between the generation and the usage through the smart grid really brings those possibilities. Looking at a typical home in New Brunswick, 80% of the home, this is an electrically space heated home, 80% is hot water and space heating. And then you have all the rest. So obviously there's some clear targets there and clear areas we want to look at, but that doesn't mean it's not all important. So I think we really want to look at going forward, how do we tap into and where are the opportunities? So, helping customers better manage their bills. I think that's one of the most important things, because for the most part, we're not sure on a day-to-day basis how and what our patterns of electricity usage are costing us. We find out at the end of the month. So how do we get better at that? How do we get more data, more from our meters and more intense data that we can study and actually put to good use and better manage our bills going forward? Long-term strategy. What we're talking about here is a 10-year strategy. This is not going to happen. This is not an overnight strategy. But we need to start working at it, and we have a clear vision in mind. And when we look at these curves and what took place last Thursday, and we start to say, okay, that's what we want to get to. How do we get there? But we need to go there together. We're talking 635 megawatts by 2035. If we let load grow and just continue to grow the way we've always done, just let it go, at about 1 or 1.5% per year, and someone will say, in a quiet economy, how's load growing? Have you ever seen the plug load in your house today versus 10 years ago or 5 years ago? Everything's plugged in. We got large TVs now. There's not just 1 or 2 large TVs, or maybe 3. There's the air conditioners coming out. There's a lot more load. So even in economies that are tough, people are using more electricity. So there is load growth. So how do we manage that? $1 billion in net present value, and that's critical. Offsetting the need to build, better running the system, key ingredient to our vision of sustainability to low and stable rates in the future. So the transformation is pretty clear. I mean, we've generated electricity because of the way people use electricity in the past, and we've been there. I think we've done a fairly good job at that. But the key to the future is more about the demand following the generation. So having dissected information as to how electricity is utilized and where the opportunities are there, and getting a whole lot more savvy about what's going on the usage side is critical going forward. So it really flips the equation to demand following generation. We go from a poles and wires company to an energy services provider, looking at perhaps a new water heater solution, perhaps electric thermal storage, different products that we can put out there that may help us not have to have that full 700 megawatt jump like we did last Thursday. But then we have to engage with consumers and make sure we have a value proposition that'll help consumers want to come with us. And we'll need your help for that. Like we spoke to a group this morning, provincial government employees. We're in provincial government buildings today. We need to lead this collectively. And that's why we're doing some of what we're doing today. And very excited about the announcement with Siemens and that partnership, because they'll bring some of these solutions, not just from next door, from the world to here. And then we can take it back out. So, energy services provider. So working on what is smart grid. When we look at the typical usage of electricity and what Efficiency New Brunswick has done over the past, you take the top one on investment. These are steady reductions, new windows insulation, new energy efficient lighting. Where when you make that change, it's a permanent reduction. It's a pure reduction, and Efficiency New Brunswick does a good job with programs, and we're working with them hand in glove with this program. The second one down, when you look at behavioral, there are programs being developed today to change customers' behaviors to help reduce peaks, network congestion at times, by having some kind of a motivator to go off the peak and into the valley. But that's a behavioral issue. The customer has to make that change. The third one down we see is a trust issue. If we have 220,000 water heaters out there and we're interconnected to all of them, and we can ensure that everyone gets hot water when they need it, however, we also would like to make sure that we don't have those hot water heaters heating the electricity on peak. Or maybe it's not a peak day that we're worried about. Maybe we want to better align it that day because the wind happens to start blowing at 2 o'clock in the afternoon. So how do we correlate that? So this is direct load shifting. And this is a new dimension because there's a trust there. Because now we're actually working with some loads in the home. But for the customer, if they can have hot water and heat, and we can flow electricity to those devices at more strategic times, that's a good thing. So that's a bit of what we're talking about going forward. So investment, behavior, and trust. So again, we're going to have to work at that. We're going to have to work with our customers, and that's the road to the future. Improved tools. What can we expect to see? Improved tools to better manage electricity bills. Two-way metering, in-home automation, in-home dashboards. So getting better hour-to-hour information. Real-time electricity consumption data. Big data conference last week when we put 250,000 meters out there collecting data every 10 minutes versus getting this data once a month. We're talking reams and reams and reams of data coming in. That's got to be managed. It's got to be intelligent, right? So a more dynamic relationship with NB Power. People will expect us to know more about what's going on in their home because they're going to want to know more because they're going to have better diagnostics. So they're going to want to say, so what happened in the last hour? And what about this home heating system? So our energy advisors are going to have to step up their game. And that's the new day. There's actually companies being formed in the U.S. today that do just that, provide energy advice. New products, smart water heaters, smart appliances, thermal storage. The last one is the LED street light replacement program. We're replacing 72,000 lights, street lights across New Brunswick, and we'd encourage all of you, when you see us in your neighborhoods doing that, you can speak to your neighbors about the fact that these lights will use 27,000 million kilowatt hours less than they do today, just the new lights that we're putting out there. It's a key part of the future. We have someone from LED roadway lighting here today, Chuck, and welcome. I think that's critical, but I think it's working together, and this is going to be a very visible thing out there in New Brunswick, and we really need all of you to work with us to promote this kind of thing, because it's part of where we're going in the future. Here we go. What's in it for me? Enabling rate stability, more choice, control, information, and programs. I think we've talked about that. It's really the gas analogy. It's having that information to better manage bills going forward. And for some, it may be reductions in bill, but for some, it may be just being able to better manage future growth, because people will use more electricity, and some will use less. But how do we better manage those increases going forward? And having that information will allow that. Improve system reliability, improve power restoration and outage management. Very critical. Today, at your cottage, if the power goes out in one or two residences, we may not know. Or if you're away from your home, usually how we find out is people call in. With intelligent data out there, with a meter on a home, we will know that the power is out at that house. Okay? That's very important. As well, improved efficiencies with automation, fewer truck rolls. Today, when we do a disconnect reconnect, we roll a truck out to take a reading on a meter, or at least get a drive-by reading. In the future, that's a quick in and out. That will reduce truck rolls by tens of thousands on an annual basis. We talk about becoming a top quartile utility. This is essential, part of the smart grid. Enhanced outage management, being able to have diagnostics on the system so that when there's an outage, we can isolate it because there's automated switching taking place. It isolates so we can restore power to the people around the fault quicker, more effectively. That's what's in it for the customer down the road. It's a big part of smart grid. A lot more automation on the system. So that's a bit of where we're going. So not just is it that end-to-end connectivity where we understand a lot better what's taking place and we can generate more effectively, it's a lot about managing that network more effectively. So a few of the initiatives we've got going on, the 10-year Smart Grid Roadmap with Siemens. I mean, we've had the official office opening today. Great day, very exciting. And we will continue that. A solid partnership. We're a world-class partner here in New Brunswick. They bring global solutions. We have to connect them to New Brunswick. We have to connect this whole thing to New Brunswick. The people we spoke to this morning. That's the challenge and the opportunity. Because these projects are as much customer and social as they are technical. It's probably 80% customer and 20% technical at the end of the day. Because it's really changing behavior. But for the right reasons. 3-year plan with efficiency New Brunswick. New Brunswick Power and the 3 municipal electrical utilities working together on that 3-year view and saying, okay, if we don't want to burn electricity during those peak times, perhaps we want to co-promote an electronic thermostat program going forward. So we're working hand in glove on a 3-year plan aligned with the blueprint that will come out at the end of April that will start to target and identify programs that are win-wins. If we can shave those peaks and give customers programs for electronic thermostats that helps them better manage their bill, and we can manage that peak more effectively, that's a win-win. That's really what we're looking for. And Power Shift Atlantic, it's an R&D project we've had going on, wind integration through load control. And that's been very exciting. We're about 2.5 years into a 4-year project. We've won a few national awards last year, and it's going very well. The partnership with Siemens, 10-year partnership, 40 jobs, and Richard will allude to that, so I won't get too far down into that. There's currently 23 on the ground here in Fredericton. Center of Competency with an R&D team. They've moved their R&D team from Princeton, New Jersey to Fredericton. That's the commitment Siemens has made to Fredericton. They are relocating a complete R&D unit from Princeton, New Jersey to Fredericton, which is great. Project management team is setting the foundation, and that work is going on presently. And we're working on innovation in New Brunswick. What can we expect to see? Home automation and communications down the road. New technology demonstrations. Pilot projects in the commercial sector, leveraging the ICT sector and local engineering firms, getting better diagnostics with how electricity is utilized for some commercial and industrial customers. So there will be pilots and demonstrations in these areas. New water heaters, new solutions to the future. And bringing these solutions together so we can start to expand. The virtual power plant system design, and when we say the word virtual power plant, is if I had a connection to every water heater in every one of your homes, brought back into one intelligent load management system that could send signals out and actually control each one of these water heaters at different times, that's what we're talking about. It's a central system that receives a signal that says the wind's about to stop blowing or the wind is about to pick up, so let's pick up some load, so that just sends a signal out. When we talk about a virtual power plant, that's really what it is. It's using load for a power plant. Efficiency New Brunswick, 3-year plan with a 10-year view. Benefits flow from efficiency programs. I mean, the cheapest kilowatt hour is the one we don't use. We're working with the 3 municipal utilities. I know Edmundston Energy's here, St. John Energy, and Perth Andover, hand in glove with Efficiency New Brunswick, coming up with a 3-year plan to help New Brunswick businesses and homes better manage their electricity bills. That'll come out in April, so we're working on that in parallel. So the Power Shift Atlantic project, I'd just like to go through a few quick slides here to show some of what's taking place with Power Shift Atlantic and some stuff that we've got on the ground today in government buildings. It's pretty neat stuff. Thermal storage. heating with bricks on the back shift, 11 at night to 7 in the morning, or when the wind is blowing, trying to optimize when we charge units. Power Shift Atlantic, if just getting back, it's a clean energy fund. It's an NRCan project. It's a 4-year project. We're about 3 years into it. And really, it's about wind integration. It's about when the wind blows and the wind picks up, where can we put it? And if the wind's about to curtail, how can we back things down? Because today, when the wind stops blowing, something's got to pick up, right? And the question is that dynamic relationship with customers and loads and creating that possibility, because there are loads with flexibility. When a municipality fills a water tower with water, those are huge pumps. They don't necessarily have to start on peak, just as long as that water tower is filled. There are many loads like that we can put intelligence in and optimize. Just as long as the water tower is full, just don't charge it on peak. But today, there's really nothing telling it to do anything different, right? So that's that relationship with load. Electric storage in buildings, Hampton Middle School. We've got 5 80-kilowatt units. These are bricks in these units. They heat the bricks at night instead of on peak. They release the heat during the day. These are in situ right now. So our Power Shift Atlantic team, we've got some folks here. They're led by Dan Gaudette. They're doing a great job. And this is innovation. It's hard work. It's heavy lifting, okay? It's new customer relationships. But it's really exciting. And people are engaging into this stuff because it's meaningful. It's really meaningful to say, how do we better run this system and become more efficient about what we do? People see that this is worthwhile. It's good work. And that's what we're talking about here into the future. Electric thermal storage at Woodstock office. Again, these are bricks, and they heat hot air blows through these bricks and heats the ducts. So, and I'll show you a little bit on the bricks. This is what we're talking about here. Just brick furnaces. You can get baseboard heaters for rooms with the same concept. And these are the hot air furnaces. But if you look here, this is our old baseboard. That comes on when we all get up last Thursday morning. Everyone turned it up a little bit maybe. These things come on. Peak goes, shoo. These things here are baseboard heaters in the UK. They heat bricks, okay? And they heat them from midnight to 7 in the morning. They have 6.5 million of these out there in the UK. They've been doing this since 1960. So it's not a foreign technology. So perhaps there's solutions to the future that are different than what we've done in the past. I think, Don, you alluded to that. The future may be different than the past, and this is part of what we're talking about. Moving on, again. Now, going from the peak into the valley. That's what we want to do in the valley. And I'm going to show you what the UK is doing to put their loads into that valley, okay? Electric thermal storage in the UK. If you see here, there's 6.5 million storage heaters charging in the UK. Oh, get another light here. In the UK, 16,500 megawatts of load charging on December 7th, 2010 between midnight and 7 in the morning. That shaves an equivalent of 7,000 megawatts off peak. 8 large generating units. So this is not foreign. This is actually going on in the world today. So it's an example of perhaps where we need to go in the future. But again, putting it into the valleys. What loads can we get into the valleys? We talk about charging electric vehicles down the road and wanting to promote electric vehicles perhaps. We're definitely going to want that load in the valleys. You're not going to want that load on peak. So we've got to go in with our head up and understand what we're doing as new products enter the marketplace. Working together, this is the closing slide. We're glad to know that, eh, Dawn? We're good. If we look at the left axis, the vertical axis, cost of the electricity system. If we go it alone and we do nothing, the cost of the electricity system will go up. Status quo, 1.5% per year, load growth will continue, 635 megawatts. We can do some things ourselves on the smart grid, put more intelligence out there, get these automated meters out there, get some automation on the grid, and enhance the system to some degree. But the real magic to the future of electricity, the real magic is in how we use electricity. And the real opportunity is a smart grid and leveraging this information to make our whole system, and we got the opportunity to do that right here in New Brunswick. to make our entire system more intelligent and take that to the world. Because there's a lot of utilities that are watching this already. And the world, and there's global headquarters Siemens watching us now. So we have this opportunity, and if we want to take it, and working together will take us right down here. Low and stable rates, sustainable electricity, better integration of renewables, and reduce our dependency on fossil fuel, and hopefully offset the need to build that unit down the road. So that's really what I was here to talk to you about today, and thanks for your attention.